I won't be taking much of our time, so we'll be looking into a course which is titled Linear Algebra, and specifically the course code is MTH 311 Linear Algebra, MTH 311 Linear Algebra. So the topic here is system of linear, one table content, the system of linear equation and linear combinations of vectors. So from what I have here, the general system 3.2 of the linear equation may be written as the following vector equation: x into the scalar value plus s2 into another set of scalar to the variable xn to the nth value of a scalar to give you the vector. Now record that vector v in Kn is said to be a linear combination of a vector. This you want you to use if Kn in Kn, if there exists a scalar in K such that v equals to this. Now, so what we intend to talk about here is that whenever a vector, let's say v, can be expressed in the form of a variable x multiplying a scalar a, whichever way you write it, unless for example it's like this. I mean, if it's written like this, where b is the vector and then x is the variable and a is the scalar. So if a vector can be expressed in this form, then we say b is written as a linear combination of the scalar multiplying several scalar multiplying sum of several sum of multiplication of the scalar and the variable. So that's that. So how do we solve questions? How can we express a vector as a linear combinations of other subvectors? So we say something called subspace in a linear algebra. So, but let's go straight to this question. It says that, okay, suppose we want to write the vector, this vector as a linear combination of these three vectors. So, but do not forget that this vector v will be written as a linear combination. That is the sum of the multiplication of the scalar, several scalars, and you can say choosing variables, scalars a, and choosing several vector a, and choosing variable x. So now we have, these are the three subvectors of space of this vector v, and then now we are expected to write v as a linear combination. So, but since this is three-dimensional, so we are going to have three sum. This will be expressed. This vector will be expressed to be the sum of a variable multiplying all these subvectors of space u1, u2, and u3. So we have x multiplying vector 1 1 1 1 1, and then u2 we have y multiplying 1 2 3 2 and 3, and then we have z picking z as another variable of 2 minus 1 and 1. Do not forget that we are expressing v to be the linear combination of what? Of all these. So 1 minus 2 and then 5. So what I'm going to do now is this. I'm going to take away all this. I'm going to take away everything now and show you. I'm going to show you. So we have this vector written as a linear combination of that, and then we have this, that. So that's it now. So from what we have here, we have 1 minus 2 minus 5 as this. So we can then open up the the matrix or the vectors. So we have can repeat this. We have 1 minus 2 5. Can repeat that, and then we're going to have this. Then if x multiply this 1, we're going to have s. X multiply this, we're going to have ss. So everything will be x, and then y multiplying this will be y, 2y, and y times 3 will be 3y. So and if z multiply all this, we're going to have 2z minus z. This multiplied by the z multiplied by 1, we're going to have z. And everything we have here is equals to this. So we can add up vectors. So you know that vector v1 plus another vector v2 this form is the same as putting them together. v1 plus v2 separately, whatever value we get is the same. So we can say we can add up these vectors. S plus y plus 2z, s plus 2y minus z, s plus 3y plus z. So that's what we have here. S plus x plus s x plus y plus 2z. That's what we have here. And x plus 2y minus z. That's what we have here. S plus 3y plus z. That's what we have here. So that's what we have there. So everything, do not forget that everything, all what we have there is equal to this. All we have there is equal to this. So then we can then move down, and then what do we do? From our knowledge of Gaussian elimination method, or Gaussian whatever method, or row echelon reducing method, here there's no need to make use of the canonical method. So from what we have here, we can have x plus y or s plus y plus this equals to 1, s plus 2y minus z equals to minus 2, s plus 3y plus z equals to 5. You can have that, and then proceed. So we can have s plus y plus 2 equals to this equals to this, and s plus 3y plus z equals to 5. So from what we have here, by row reducing, echelon reducing, that is, we are trying to get the value of x, y, and z. So now by echelon, reducing this, from what I have here, how do I go about the reduction? So this and this is the first row, this is the second row. So I want to use this to reduce this. I want to use the first row to reduce the second row and the third row. So I can easily say, since this is 1, coefficient of this is 1, 1, and 1, so it's easy to reduce it. I just say row 1 to remain, row 1 should be row 1, and row 2 becomes row 2 minus row 1. So I think that we cancel out row 2 minus row 1, and then same thing goes for row 3. Row 3 will be row 3 minus row 1. So whichever way we're going to have, if it's going to be row 2 minus row 1, that will be this minus x. The next one, I'm going to have this to be row 1 because of 1. I'm going to have s plus y plus 2z equals to 1, and the next one is going to be, this should be, just to subtract, this to subtract this, s minus s will be 0, 2y minus y will be y. So I'm going to have just y as the second, just going to have y here, y, then minus z, minus 2z, I'm going to have minus 3z, z, then minus 2 minus 1, I'm going to have equals to minus 1, equals to minus 3, So we're going to do the same thing for the third one. So that this minus this will be 0, 3y minus 2 minus y will be 2y. So I'm going to have 2y here, and then z minus 2z, we're going to have z minus 2z, we're going to have minus z equals to 5 minus 1, we're going to have 4, and it equals to 4. So that's what we are going to have. So by reducing that, and then we're going to have this, that I wrote there, and then if we are going to go by reducing the third one, just say 2 multiplied by y here. Now if 2 multiplies all the values of y and we subtract this, we're going to have 0. So row 3 will just be row 3 minus 2 multiplied by the row 2. So 2 multiplied by y, then 2y minus 2y will be 0. Then 2 multiplied by this will be minus 6. Then minus z minus negative 6 will be minus z plus 6. That would be 5z equals to minus 2 multiplied by this, minus 2. So what I'm saying is this. So when this is 0 already, so by if I say 2 multiplying this, then this minus this. So 2 multiply this is minus 6z. So minus z minus z minus minus 6z minus will becomes plus 6z. So we're going to have minus z, so we're going to have 5z. Okay, minus 2 multiplying 3, minus 3, we're going to have minus 6, then 4 minus we're going to have 4 plus 6, we're going to have 4 plus 6, and that is 10. So, and that will give birth to the next thing we're going to have. We're going to have 5z here, 10. So